Hello, everyone. My name's Kathy. I'm one of the Android engineers here at Lyft. And today I'll be talking about building, launching, and iterating on Lyft Shuttle, which is our newest commuter product. So before I get into that, first I want to introduce myself a little bit. I graduated from the University of Waterloo, majoring in computer science. Before Lyft, I worked at A9 Visual Search in Amazon to help build out their mobile computer vision framework. And so at Lyft, I've been here for just under 2 years, and my team mainly focuses on building commuter products, namely Carpool and now Shuttle, which I'll be talking about today. So first on building. First question we have to ask is, what are we actually building here? What is Shuttle? Who here has heard of Shuttle? Hands. Who thinks it's a bus? No, hands down. Okay. That's not what it is. So let's get to explaining what it actually is. So if any of you have taken Lyft line, it's very much like that. It's a shared ride. What this means is when you request a ride, we try to match you with people who are going the same way, so you guys can share a ride together. What differentiates us from Lyft line is the fact that we have fixed stops. And what this means is instead of a door-to-door service where we pick you up right where you requested, you would have to walk to a pickup stop and then walk from your drop-off stop to your final destination. And another thing that differentiates us is the fact that we have a fixed fare. And what that means is it's not going to be affected by prime time. What prime time is basically our dynamic pricing model where if the demand is too high and we don't have enough drivers to meet that demand, we raise the price to encourage drivers to get on the road to meet the higher demand. And with these fixed stops, when you request, you can kind of see like the general route that you'll be taking. And this is very important because if you've ever taken a Lyft line in downtown San Francisco or anywhere where it's very dense, there's a lot of one-way streets. Sometimes you could get matched to someone who's just a few blocks away, but it turns out to be a massive detour, and now your ride is much longer than you anticipated. And we wouldn't want you to be late for your meetings in the morning, and so we thought this was a very important feature to build into this product. And of course, if we can get you to work with Shuttle, we want to make sure that you also have a ride home. And so for almost all of our routes, there is a reverse route in the evening window as well. And finally, as commuting is a big part of people's day-to-day schedule, it's a habit that people form. We recently launched a scheduling feature for Shuttle, so you can actually schedule your commute for up to 7 days in advance. So looking at this set of features, some of you might be thinking, well, isn't this just a bus? And Twitter had a field day the day when we first launched it to the public. And it was very interesting to see people's reactions and interpretations of what they think Shuttle is. And so there was one tweet in particular that caught my attention. Around the time that we launched, there was a bus in Brooklyn that rolled back and hit a bunch of parked vehicles. Thankfully, no one was hurt in the accident, but then someone replied saying, well, Lyft Shuttle wouldn't have done this. And so that might be one interpretation of what Shuttle is, how is it different from a bus, but in all seriousness, actually, our Director of Transportation Policy, Emily Castor, wrote a really great Medium post on this topic. I highly encourage you to go read this. I won't cover all the details in there, but there are some highlights in there that I want to talk about. So we believe there's a place for a service like Shuttle that will actually complement local public transit systems. And what we kind of want to categorize is a flexible microtransit service. And we'll bring capacity into the system when and where it's needed most. For example, it could close the last mile gap. So the last mile problem is a classic problem in transportation where most people actually live just outside the sweet spot of a transportation hub. So it might be too far away to walk, but just kind of close enough that you might not want to drive there. And so we believe that Shuttle could be there to kind of fill in that gap. And in areas where it's underserved, there isn't enough density, for example, not necessarily a very highly dense city with lower capacity vehicles, Shuttle can also fill that gap. And it might be a bit counterintuitive, but you actually don't really need a very highly dense area to support something like a fixed route. The reason for that is you can imagine if you have 4 passengers who want to be in a car together, if you can match all of them together, then you've already filled a full car and taken 3 other cars off the road. And of course, in areas where it's just too crowded and the local transit can't support it, shuttle can also be kind of a flexible alternative for them. Recently, my team took a field trip to Chicago, and one of the popular commute options there is to take the L train. But during commute hours, it actually gets so packed that sometimes when the train comes, you can't even get in because there's just no space. So in situations like that, we believe a shuttle can be a good alternative as well. So hopefully I've convinced you that this is a product worth building. It has a bunch of unique features. And so how do we actually let people take a shuttle ride? Now, the first problem that we encountered is how do we actually generate all of these routes? And our data science team was heavily involved in this process. What we want to do here is basically create a cluster of home and work locations. We get this data from the public census data and from internal Lyft data. You can see here, this is our employees and morning demand for taking Lyft rides. You can see on the left there is all the home locations you can see spread out throughout San Francisco. And on the right, there's no surprise that in the morning when we take rides, we're mostly commuting to work. And so indeed, the red dot is exactly where we are sitting right now. It's the Lyft headquarters. And so taking all of these clusters, we try to fit as many routes as possible to maintain good match efficiency. And the thing that we kind of want to evaluate here is a trade-off between two things. One is matching efficiency. And what is that? We define it as the percentage of overlap between passengers on a route. So you can imagine if two people were picked up at the same place, dropped off at the same place, then we have 100% match efficiency. This is really important to maintain a very sustainable price point. And this is something that we have to trade off with walking time. So if, say, we just have one route in San Francisco, everyone needs to go to that route. Well, they may have to walk 20 minutes, 30 minutes. Well, that's not something that people would be willing to do. So if we add more routes, adding more stops, then it's a trade-off between matching efficiency and how far people are willing to walk. And so now that we've generated all these routes, how do we actually match people to take a ride on one of these routes? So very much like Lyft Line, if you've ever used it, you have to enter in a pickup and destination. And after that, if there is a route that's matched to you, we show a toggle in the middle of the screen that gives you the option of taking a shuttle ride. One thing to note here is that we're actually guaranteeing an earliest departs at time. When we dispatch you a driver, we take into account how long it takes for you to actually walk to the stop, so we don't dispatch you a driver that's too close and they will drive off without you, or they would have to sit at the stop and wait for a very long time. And as you can see here on the map, we have a few kind of custom map components that's not natively supported. We've got gradient lines, we've got dotted lines to support, to show like a walking route. And so that was kind of one thing that we had to do on the client side to hack basically Google Maps and to actually show these routes. So how do we actually do this? The first thing is gradient lines. This is actually supported by the iOS Google Maps SDK, but not Android, go figure. Two things are important here. One is that it enforces directionality. You can see that the colors match to pick up and drop off points to show that you're actually going in one way on the route. Another thing is it's a product distinction. You look at the screen, and it's very obvious that you're going to be taking a shuttle ride versus, say, a Lime ride or a normal Lyft ride. And so we're actually leveraging the fact here that Google Maps is pretty good at rendering a lot of different polylines. But before I get into that, what is a polyline? Polyline is defined as a list of latitude and longitude pairs. So for example, here we see 7 pairs of lat long. You connect all of them together, and you have a polyline. And so how do we actually render this with a gradient? So given some kind of start and end color, and the list of lat longs, we want to figure out how many segments you actually need to render this gradient. You can imagine 2 colors that are very close together will require less segments than 2 colors that are very different. And so for each of these in-between colors, we want to create a solid color segment and figure out when they start and stop so that it creates a nicely blended gradient. So that might be a bit hard to digest. So here's kind of like a simple visual diagram of how it actually works. Imagine this is your list of lat-long pairs, points that are not uniformly distributed. What we want to do is break it up into a bunch of different solid segments and then merge them together into a gradient line. And so on the map view, this is kind of what it would look like. Starting from the purple, you start adding in all of these solid segments. And in the end, you have a very nicely blended gradient line. So the next thing that we had to do is dotted lines to show where you're actually walking to. If you're familiar with the Google Maps SDK, you might know that they recently added support for this through pattern item. When we launched the product, this was not supported. But one advantage of our own implementation is that because we're just drawing a bunch of dot markers, we control where each marker is, which means we can even add animation to this. So we can show a direction of where you're walking to. And so very similar to gradient lines, you have a bunch of lat longs that form a polyline. You're breaking them up into even segments and just putting a marker in between each of these segments. All right, so now that we found your route, how do we actually explain this product to people who don't necessarily have a pickup and drop off that is close to a route? How do we kind of explain the system of routes and the whole product that we're actually offering? And so routes visualization actually turns out to be a pretty hard problem. The first version that we went with was a very optimistic kind of outlook. On the left was a mock that we got from our designers. It has a bunch of some beautiful gradient lines with markers to indicate where each stop is. But an issue with this is if you have a bunch of overlapping routes, it actually turns out to be indistinguishable from each other. So this is downtown Chicago. You can see the routes kind of mingled together like this spaghetti monster, and you can't tell any route from each other. And so we iterated on this and came up with a second version where we focus on the relevance of each route. So in this version, we highlight the nearby routes based on where your pickup pin is, and we dim the ones that you can't actually get matched to, since you probably don't care about those at this point. But again, this was kind of what we expected it to look like, and it turns out, well, when you have two routes that are very close together, again, if they're overlapping, they kind of connect into this gigantic route, and you can't tell them apart. So again, we iterated on this approach and came up with a version 3 that we ended up launching into production as an experiment. So what we're doing here is using motion to differentiate the routes. So you can see we've kind of cleaned up the map view. We've gotten rid of the stops. And as you're moving the pin around, we're still highlighting the nearby routes, but we're cycling through them using an animation. And similar to before, we're also dimming the routes that you can't get matched to, so it's not too distracting. And so this is kind of like all these different features that we have built for this product. Now it comes time to actually launching it. There are so many things that you don't know, and how do we actually mitigate the risk of launching a completely new product? And I think there's something unique about the Lyft experience where most of your experience isn't just in the app. It also involves interacting with the real world, with getting picked up, talking to a driver. And so there are a few things, for example, like walking time. You could be in the office, you request a ride to go home. Well, now we also have to take into consideration the time for you to get down the elevator, go through all the traffic lights. Maybe there's construction right by the Caltrain station, which is really annoying. And how do we take that into account when we're dispatching you a driver? And when you actually get to the stop, that pickup and drop-off experience, how do you find your driver? How do you know where your stop is? When you get dropped off, how do you know where to walk to your destination? Another thing is real driver behavior. When we're testing this, we can assume drivers would behave perfectly, but you might know, of course they don't. They might cancel rides, they might be late, they might refuse to do certain things, or they can't find a stop. So all of these things need to be taken into account. And this whole end-to-end experience from you requesting a ride to actually rating your driver and doing the payment part of it is something that needs to be tested. And so with our rollout, we had a pretty deep detailed plan of how we were going to do that. So first, we started off with team testing. Of course, we test it in what we call a one-box environment. So a one-box is something that we use where it's like a simulated Lyft environment where we control all the passengers and all the drivers. So we can be a fake passenger that requests a ride, and we have a fake driver coming to pick you up using fake GPS data. And once we've kind of tested the entire flow with fake location data, we actually go into the field to do some production rides. And so what we did was turn on the passenger experience in our own apps, and then went out to do real rides with real drivers. And what they see is basically just the Lyft line experience, that they're just picking up different passengers. And after that, we kind of increased our audience to all the employees at Lyft. So at Lyft, all the employees are on alpha and beta builds for a week before it goes into production. That helps us not only get very valuable feedback for any new features that we're building, they also help us find bugs. And so, in fact, we did test it extensively for 3 months before we even launched it to the public. And finally, rolling it out to production, we started off with a very low percentage just in San Francisco. And as we're monitoring all our crash boards and whatnot, we slowly rolled it out to 100%, both in San Francisco and Chicago. And so ultimately, the question that we're asking is, well, did it actually work? Did we build a product that people want to use and they had a good experience? How do we actually measure that? And so this part comes as iterating, which is our current stage of the product. And Lyft actually allows us to do really rapid iteration because we have weekly releases. And in fact, we've leveraged this and we've launched almost a new client experiment every 2 weeks. And other than client experiments, we've also done experiments on the server side, like selling ride passes and subscriptions, where you can purchase an X number of shuttle rides for some very lowest price point. So we're hoping that you can be a returning passenger and use it for your commute every single day. Another thing that we tried to experiment with is people's willingness to walk versus how much they're willing to pay. Would they be willing to pay a little bit more if they didn't have to walk so much? So we had to adjust a lot of parameters to make sure we find that sweet spot. And of course, because it's a new product, we want to be selling this on, say, the ride receipts that you're getting in your email after you finish taking a ride, and marketing pushes. And with all of these experiments, we try to follow a pretty rigid template to make sure that this is actually measured correctly and we get valid results. So here are some of the things that we need to consider when setting up an experiment. First thing is, of course, the hypothesis, like what are we actually trying to test and what we expect to happen. And we have to define the experience of what the user is actually getting. What is control versus a variant of treatment that they get. And exposure, what this means is it indicates a point in their experience where the experiment would actually affect what they see. And so you have to be very specific here to make sure that the users that you're targeting is only those are included in your test analysis. And with the duration, we have to figure out how long we have to run this to get statistically significant results. We have to take into account the number of users we have, the number of rides we take every single day. How long do we have to actually run it so we actually see significant impact? And of course, we have to have a success criteria for when the experiment ends. How do we decide that we're actually going to ship the treatment versus reverting back to control? And finally, any kind of analytic events that we need to add in support of this experiment needs to be defined in advance so we can add them in when we launch the experiment. And so in addition to experiments, there are a few other feedback channels that we can leverage to iterate on our product. One thing that we do very early on in the process is, of course, user research to see if we're actually heading in the right direction. One story that I've heard from our user research team is they actually went out to a bar to talk to people who are in their less than sober state, so they can actually talk to them in the same state that they would request a Lyft ride. So I thought that was interesting. Another thing is, as I mentioned before, dog fooding. All our employees use our beta builds, but one thing with employee testing is it turns out employee behavior isn't necessarily the same as your average user. What we found was that because employees want to test Shuttle, they end up being willing to walk a lot further than what the average user would do. And so after we launched, we actually had to adjust that parameter as well. And serving our actual passengers and drivers. There's one thing we do at Lyft every quarter where engineers look at tickets and actually talk to real passengers and drivers to get a direct line of feedback. And so we did that for Shuttle as well. And this last thing isn't quite a feedback channel, but I thought it's something really cool, is that we actually can use past data and try to predict the future using that. So for example, we can take all the Lyft ride requests from yesterday and change our matching algorithm and see what changed, how would that change our match rate. And that's something we call simulated rides. And so with all of these things, what we're trying to do is we want to make sure that wherever you go, you can take a shuttle ride. How do we actually scale up to having 10,000 rides in the US? How do we actually do that? And in order to solve that, we have to figure out, well, how do we deal with in areas where there isn't enough density to support many routes? And similarly, if you want to take a shuttle ride and you happen to be in an area where there really is just no route for you, how do we solve this, what we call a dead-end experience? And as I mentioned before, the last mile problem is very important as well, as how do we actually work together with the local public transit service to fill that gap? With enterprise, that's a perfect use case. We know exactly where they're going for work, and so how do we kind of build routes around that are tailored for their employees? And with scheduling and frequency, this actually is extremely helpful when determining match efficiency. If you can predict people's demand in advance, and if you can match people together in a bigger window, then we can get higher match efficiency, which is very important for financial sustainability. And so with all of these different problems that we're solving every day, we're kind of redefining what we're actually building. What is actually shuttle is the problem that we keep going back to. And so our current North Star is that we want to create a reliable, sustainable, and affordable commuting solution. And so if you're interested in helping us build that, please come talk to me afterwards. Otherwise, that's all I have. Thank you.